think we're up through section 3.2. We've done all the tangent stuff, had some worksheets, anything. I think we did through worksheet 5 and up to like the 26 or something in the homework set, I think have all been assigned. Not that they've necessarily been due yet, but I see people flipping, so I'm just going to kind of continue to awkwardly fill the empty sound or empty fill. I don't know. Listen to myself talk while I see if anybody has anything. Going once. Going twice. All right. Sold. No questions. Very good. Today we're going to finish up Chapter 3, talking about harmonic motion. Since we're finishing up Chapter 3 today, what does that mean next week? Yeah. Probably looking at Wednesday next week, just as a heads up. Yep. Yup. All right. So harmonic motion, what are we talking about here? We're really talking about real life situations that can be modeled by using one of these sine or cosine functions by writing a sinusoidal equation. So the two most common situations that you'd see in real life where one of these sinusoids would be appropriate. Oh my goodness, what just happened here? What is going on? Is either you have something that spins or you have something that's kind of moving up and down. So let's look at a couple. Yeah, Morgan?
So when will the test be? Because we don't have class Wednesday. It's AP, right? On my calendar.
Okay, Thursday. Sorry.
Okay, thank you.
Yeah, the second class day. My apologies. Okay. So again, kind of two different situations that we'll run into that realistically using a sinusoid would be an appropriate way to model that situation. So you have things that are spinning, and then you have things that are moving up and down. So here it says a 100-foot diameter Ferris wheel is positioned with the center of the Ferris wheel 55 feet off the ground. The Ferris wheel spins at a rate of 1 revolution per 2 minutes. Construct a function to model the height of a rider, where height is measured in feet and time in seconds. And the rider enters the Ferris wheel at its lowest position. Okay. So, let's start by maybe drawing ourselves a picture, right? So, here's going to be my Ferris wheel. And we'll call this spot here, looks like about the center. So, I don't know, this looks maybe more like a hamster wheel or whatever, but this will be my Ferris wheel. It says that Ferris wheel has a diameter of 100 feet. So the radius then is 50. And it says the center of the Ferris wheel is positioned 55 feet off the ground. Everybody's okay with that? So that's my picture. Now it's asking me to model a function h of t, where h is the height and t is time. So I'm going to have the points on my graph would be time, comma, height. Everybody's okay with that? And it says that, let's see, it spins at a rate of 1 revolution per minute or 2 minutes. Not quite sure what to do with that yet, but I'll write it down. And then it says, oh, the rider enters the Ferris wheel at its lowest position. So right here would be where we enter at. So maybe we have like a little extra ramp here for a person to get into the Ferris wheel. Everybody cool with the picture that I've drawn and the information I've recorded? Do we see how this is a sinusoid? Let's just kind of talk our way through it so that when I show you the shortcut, it makes sense as to how we're doing it. So let's say that this is our time and height graph. Okay? So our first point would be here as you're entering the Ferris wheel at time 0. What's the height of the person at time 0? It's not 0. 5. How could you tell that?
55 minus 5.
Good. The diameter of the Ferris wheel is 55. Or, I'm sorry, the diameter of the Ferris wheel is 50, and it's 55 feet off the ground from the center, so. Okay. We'd have like here. And then this point, we'll just call that, say, T1. What's the height at that point? Not 50, 55, right? Everybody agree from the picture? And then let's say here we'll call this T2. What's the height at that spot? 105, right? It's that 5 feet up from the bottom, and then the 100 diameter. And then let's call this point like T3. What's the height there? 55 again, okay. And then we'd be back down here, maybe that's T4, back at 5. If we go around another time, maybe that's then T5, we're back at 55. And then T6 up at 105, and you can kind of see what's going on now, right? Everybody kind of see the sinusoid now? Yeah, I think so. All right. So shortcutting this through, what's the value for K here? What is it? 55. That's good, right? The midline here is at 55. That's my value for K. So presumably, as long as it's at the center of the Ferris wheel, the height off the ground is going to be your k. If it's not at the center, then it's a different story. Everybody's cool with that? So if it's not that case, you might have to draw the picture. But as long as it's the center of the Ferris wheel is this much above the ground, that number is just going to be your k. Unless it's something silly where it's like, it's 100 diameter, but it's positioned 30 feet off the ground or something where it's like, is this underground somehow? Or you have like an underground Ferris wheel or something. Which I guess you could have, but that would be weird. I think they exist. Or part of it's underground anyways. Anyways, continuing. How about the amplitude? What is the amplitude going to be? 50, right? What's that equivalent to? The radius of the Ferris wheel is just going to be the amplitude. Everybody's cool? Okay. So this much was a period, right? So we started here at time 0, and we end here at what time? Two minutes. Because I know one spin is 2 minutes. Aha, that's how we were going to need to use that. We wrote it down. We weren't sure what to do with that. That's going to give me my period. So I know then that like 1 period is equal to 1 spin. So 1 period is, I'm going to do 120 seconds since it said to use t in seconds in the problem, right? Time is measured in seconds, so I'm going to write 120 seconds instead of 2 minutes. So 2 pi absolute value c is equal to 120. So c is equal to 60 over pi, or negative 60 over pi. But we always do the positive one. So far, so good. All right. Then we need to decide whether we want to do a sine or cosine function. Cosine, why? Yeah, we're starting at the minimum, right? That's good. I like that plan. That's what Mr. Kulik would want to do. So because we're going from max to min, that tells me that the A is negative. And because the x-coordinate of the parent function is 0, x-coordinate of the resultant function must be my h. So I'm all done. So I have h of t then is equal to negative 50 times cosine of 1 over 60. I'm just going to start writing these as like the reciprocal. Is that okay, guys? Yeah. I'm just sick of writing like 1 over a fraction, right? We're good with just me writing that as a reciprocal now. Okay. Well, that wasn't so bad, right? So again, the takeaways. Presumably that the Ferris wheel is described like x distance above the ground from, or the center of the Ferris wheel is some distance above the ground. That distance is k. The radius of the Ferris wheel is going to be the amplitude. The time it takes to do 1 spin is going to give you the period. and then everything else is just going to come the same way we would. You find a point and you map it appropriately either onto a sine or cosine function. Now, typically, Ferris wheels, where do you enter the Ferris wheel at? The bottom. So most of the time you're going to be doing a sine unless you have a weird setup where like somehow you're entering the Ferris wheel in the middle or something. Which again, I suppose is possible if you have like an underground Ferris wheel or something. You know what I mean? Not much of a view though if you have an underground Ferris wheel. That's half the fun of it, isn't it? I don't know, I've only been on a Ferris wheel like once and it was a long time ago and I don't remember it being that much fun. But in theory, I would imagine the view is half the fun. All right. So what can we do with that? Now that we have this model, it says, using our answer, find the height of the rider after he has been on the Ferris wheel for 73 seconds. How do I do that? Yeah, we're just doing h of 73 because this is just a time. So I'm plugging this in. Okay. So, bless you. Question for you guys. When we type this into our calculator, what mode should our calculator be in? Radians, great. Why? Why do I know it needs to be in radians? That is the correct answer. I am in radians. Let me check real quick before I get too far here. What did I do in this problem that guaranteed that I had to use radians? I have a pi. That's true. Why do I have a pi there? Let's actually call it here. Because I said 1 period is 2 pi times c. 2 pi is a rotation expressed in radians. If I'd said 1 period is 360 times c, then I would need to use degrees. Now, have we ever done one where I did 360 times c? No. And that's not very standard, but if you wanted it in degrees, that's what you would have to do, is when you calculate the period, you have to use 360c instead of 2 pi c. Anyways, we typed that in, and what I got 93 point something or another, 86. We cool there? No big deal. Part B says, a woman's height is 45 feet off the ground. How long may she have been riding on the Ferris wheel for? How do I do that? What is 45 feet off the ground? That's a height, right? So that's going in for h of t. And what are we solving for then? T. All right. What do I do first to solve for t? Subtract what? 55 from both sides. That's good. Okay, what's next? Anybody? What should I do next? Solving for t. Divide by negative 50. That's good. If you know them, just shout them out. It's okay to be wrong even. It's not a big deal. That's how we learn, right? Nobody learned anything by being right all the time. Okay, now what? What do I have to get rid of next? The cosine. How do I cancel out that cosine? I don't use secant. I can't divide by... Dividing by cosine is like saying divide by square root symbol. Inverse cosine. That's what we're looking for. That's the ticket. So we'll do cosine inverse of both sides. Again, that's going to cancel over there. And then my last step would be, great, except I'm going to think about it as multiplying by the reciprocal. Is that cool, though? Feels easier than writing divides by, although that's not incorrect. It's just awkward to write. So now it's calculator time. What mode should my calculator be in? Yeah. All right. So still in radian mode. So 60 divided by pi times cosine inverse 1/5. I get about 26.15 seconds. Is that our only answer? No. Where else could I have had an answer? So if this is 26.5 comma 45, could also be over here, right? Everybody agree? Or, what else could have happened? Yeah, I gone around a whole extra time and then got there. So that plus a period, right? Or on the other side could have been that answer plus a period. Or 26.15 plus 2 periods, et cetera, et cetera. You guys get the idea, right? Now, is it okay that I report just one answer? How's the question phrased? So any of those answers would have been appropriate. Do we have any idea how to get this answer over here? Not yet. That's the subject of chapter 4. So we'll talk about how to solve equations like this and get all the solutions out of it. But you certainly could have gotten another one of these where you just added a period to it, right? That would not be a bonkers expectation.
But you just add 120.
Yep. That's correct. So 146.15 would also be an answer, or 280 or 266.15, et cetera, et cetera. How do you guys feel on that? Is that okay? Not a big deal, right? Little bit of light algebra. Now this was a circular, like things rotating example. Mr. Kulik also mentioned that you could do this, use a sinusoid to model something that's moving up and down. So let's look at an example there. All right, at 5:15 a.m., high tide comes in on Siesta Key in Florida, and the depth of the water is 18.3 feet. At 11:27 a.m., the depth of the water at low tide is 11.8 feet. A, model the depth of the water using a sinusoid function. Find the depth of the water at 8 p.m. When will the first high tide come the following day? So here we have, we have high tide, low tide, high tide, low tide, high tide. Smells like a sinusoid to me, right? Everybody agree with that? A little easier to see here that this is definitely going to be a sinusoid because we're just talking about, height and time. Everybody's cool? All right. So when I read this question, you know what I hear? I hear max at the point 515, 18.3. And then I hear min at the point 1127, 11.8. To me, this reads exactly like one of the problems from the worksheet, 5, 4, 4, 3. I'm confused now. 2. That was the number. Boy, I didn't even guess 2. There you go. Sorry. My bad. Okay. Everybody feel okay with this? Now, what's the one weird thing going on about the way I've written these points? Yeah, time is in 2 different units. That's hours and minutes, right? We need to make a decision. We need to write it with a single unit. Which unit do you want to use, hours or minutes? Does it really matter, Mr. Kulik? No, but I would pick hours because I don't want to deal with those x coordinates getting in the thousands or something here before the end of the day. Would it get to the thousands? Maybe it just, I think it does get into the thousands, right? 20 times 60 is 1,200, so yeah. So 515 as a decimal is 525 hours, and 27 is 5.45. So just if you're 0.25 times 60 is, 15 divided by 60. Goodness gracious, Mr. Kulik, is 0.25, and 27 divided by 60 is 0.45. That's where I'm getting these decimals coming from. Just converting them into hours. All right. So I remember that K is equal to Y max plus Y min divided by 2. So when I do that, I get 1505. And I remember that the amplitude is Y max minus Y min divided by 2. So when I do that, I get 3.25. Everybody's cool with that? So I have a max to a min. How much of a period is that? Half. So 1/2 of a period is going to equal the time from 11.45 hours minus 5.25 hours. Right? I know a period is 2 pi times the absolute value of c. I divide by pi, I get that c is 6.2 divided by pi, or negative 6.2 divided by pi, but shoot, we always take the positive one. So far, so good? Got k, got c, got everything but the sine of a. We need to decide whether we want to use sine or cosine, and then the sine of a and the value for h. Which one would I want to use here, sine or cosine? You should pick cosine, because what are we given? Maxes and mins, yeah. So in cosine, the maximum occurs at 0, 1. Does it matter which point I pick for my resultant function? No. I'm going to pick the first one. Since this is going max to max, what does that tell me? A is positive. Good. And since the x-coordinate of my parent function is 0, then h is the x-coordinate for my transformed function. And now I have everything I need. Everybody cool with part A? Does this remind us just like a 3.1 problem? Right? It basically turned it into the same thing, which is nice, right? Because we already did a lot of practice on the 3.1 problems. I should be pretty good at this. All right. Part B says find the depth of the water at 8 p.m. Okay, what do I do to do that? What? I just couldn't hear what you said. Okay, time. Oh, okay. Plug 8 in for t. Everybody agree? That's wrong. What do you want to plug in for t? $20. Why? It's 8 p.m. That's 20 hours since have elapsed during the course of the day. Oh, Mr. Kulik. Katie, absolutely the right idea. But you got to be careful with that AM, PM nonsense. That's why the Army really likes that military time where we just go on a 24-hour day. Which seems like kind of the better method in general, but we're going to stick to our stupid AM, PM thing because we're stubborn. Okay. So now it's calculator time. No hard feelings, Katie. I meant to trick you, but I didn't mean to. Don't take it personally. It was meant to be tricked. Okay. You seem really upset about it. Not really. And we get 16.1. So were we closer to high tide or low tide? What's the midline? 1505. Is that above the midline or below the midline? Above. So are we closer to high tide or low tide? High tide. Right? That's all I thought about. I didn't do any subtractions. It's just above the midline or below the midline. Easy comparison, right? Just as an aside. And then C says, when will the first high tide occur on the following day? Okay. So day 1, we have high tide. Well, that was supposed to be an H. Occurs at 5.15, comma 18.3. I'll say high tide number 1. When will the next high tide be on, or when will the next high tide be? It'll just be 1 period later, right? How long was a period? Well, if I take this, I know that 2 pi times the absolute value of c is 12.4, and that's 1 period. So 17.55. Oh, sheepers creepers. How long have I been writing 15 there? Boy, like the whole time, huh? Look at what I was supposed to write. What did I do like in a million places? Great googly moogly, Mr. Kulak. That's supposed to be 5.25. I know! Who's groaning about this? So this number over here is wrong. Ugh, Mr. Kulak. I'll fix it in just a second. Hold on to your horses. Cool your jets. The proper response to that would be, is jet temperature just fine? That's supposed to be a joke. Like, don't tell me to cool my jets. My jets are properly temperatured, and I'm all right to be mad about this. I know. I goobered it. You ever goober something? Yeah. All right, there. 6.26. Big difference, right? Ooh, Mr. Kulak. Hey, right is right and wrong is wrong. It's the beauty of math class, right? We don't get to debate this. It was wrong for a dumb reason, but it was wrong. All right. 1765. Are we still on day 1 or day 2? Are we into the second day? No. How many hours are there in a day? 24. It's still less than 24 hours, so we're still in day 1. Yes, sir. Sure. Okay, high tide number 3 is going to be high tide number 2 plus a period. So 1765 plus 12.4. When I do that, what do I get? 30.05. So this is day 2. So what do I say? At 30.05 on day 2? No, that's bonkers. But I do need that 30.05. What do I need to do with that? Great. So this is 6.05 hours after midnight. What time would that be? Well, if I take 0.05 and I multiply it by 60, I get 3. So this would be 6:03 a.m. And that's a better way of writing the time, right? 6.05 hours after midnight. It's like, get out of here, doofus. Tell me what time on the clock that's going to be. All right. Who talks like that? Mathematicians, I guess. What do you think here, my dudes? Is this okay? Again, not much different than what we did in 3.1, right? The whole chapter is kind of the same thing over and over again, just looking at it in different contexts or whatever. Not too bad. At this point, you guys should be able to do now 27 through 30. That's the last of the problem set here in chapter 3. And if you want, you can start the review. That stuff wouldn't be due this weekend. It'd be due like the 23rd or whatever. What's going to be due this weekend? Do we have anything due this weekend? Yeah, the tangent stuff is due this weekend, right? What was that? It was like 15 to 26, and then worksheet, was it 4, and then just like 4 and 5, or 4 and 6 or something, 3 and 6, 2 and 6. And then worksheet 5. And what do we have to do on there? Just like 1 problem or 2 problems or something, right? 5 and 7. There we go. You guys are on the ball there. No one already remembering those numbers? So that would be this weekend's. And then what do we say the test was on? What day is that? 20, what? The 20th? Is that right? I don't know. Days of the week are hard, guys. Yup. My daughter has a song to the tune of the Addams Family for days of the week. That's how I know them now. There's Sunday and there's Monday. There's Tuesday and there's Wednesday. There's Thursday and there's Friday. Then there's Saturday. Days of the week. No. You guys don't know the Addams Family because you grew up and that was already an ancient show off television. And probably not very culturally relevant. They had 2 movies when I was a teenager. The first one's pretty decent if you get a chance to see it. Raul Julia and Christopher Lloyd. The second one's kind of hot garbage. But that was the usual sequel model in the 90s. So we're going to make a sequel to something that doesn't need a sequel, and then it's terrible. You know, just for the cash grab. Probably still made $100 million or something. Marketing. The first one is pretty good, though. First one's a pretty decent movie. The right amount of like fun and plot for something that doesn't really need to exist, based on a TV show that was already 20 years old when they made the movie, or 25 years old. Anyways, I'm done for today, which is lovely.